In this video, we're gonna talk about chapter 4.7, problem 6. So this is an application problem, so it would be better if we can draw a graph. It will help us to get better understanding about the problem. So we can create an axis, and on the 0.0, this point, this will be the start point of the lifeguard. And at the point x equals to 40, which is the length of the shore, and when y equals to 60, which is the distance between the drowning kids and the shore. We're gonna just draw drowning kids. And the x will be the what the problem asking for, which is a distance that the torii should run along the shore. So x is right here. So first of all, we need to calculate the time in total. So the time will divide it into two parts. The first part is the running part, and the second part will be the swimming part. So the lifeguard gonna start from the 0.0 and run to the point right here, which is x point 0. And the velocity is 4 meters per second. So we can know the time of running is equals to x over 4 meters per second. And the second part is the swimming part. At this problem, we can just create a triangle on the axis, which is look like this. And we can use the Pythagorean theorem. On this side, this will be 60, and from the for the bottom part, this will be the 40 minus x. So we can use this number to create a equation. So the time of the swimming will equals to and because of the velocity of swimming is 1 meters per second, we just need to divide it by 1, which is just equals to the number itself. So we need to plus the time of running and time of swimming. That will be the time in total. So right now we need to find the critical point, because the minimum of the time will show up at the critical point. We need to find the first derivative of tx. So the derivative of tx, it will equals to plus the second part of the equation, we need to use the chain rule, which will equals to and times the inside, which is we need to do the further calculation, and the time in total will equals to this will be our final equation of the first derivative. To find a critical point, we need to let the first derivative equal to 0, which is let this part equals to 0, and we can move the 1/4 to the right part, so that will be and this negative sign could cancelled, and we can notice that the fraction above and fraction below all have a 40 minus x, so we can try to cancel this part. You can just move the under part on the right, so it will be this have a square root, so we need to let both part plus its times itself, so will always be square. This will equals to and we can multiply both sides with 16, so the 1/16 will be cancelled. And we can notice that the both sides all have a 40 minus x squared. So this could cancel, which is equals to and we can do a further calculation. We can move the 15 on to the right side, so it will be and put a square root. Both sides will equals to because inside the question requires us to use the decimal places. So we need to figure out approximately the decimal part. And the x will equals to 40 minus and the x will approximately equals to 24.508 meters. So this will be our final answer.